did he naturally start counting at? 1. That's right. He didn't start -4, -3, -2, -4. He didn't start counting. He naturally started at the number 1. Usually kids start counting on numbers like fingers, right? 1, 2, 3. And then they're like in 4th grade. They're still counting on their number fingers. Just counting their fingers. It's kind of awkward. Like, stop using your fingers. Where do you start with? Usually counting with your fingers, right? Okay. Not saying that's a good idea. Just saying that's what happens. So, right here in the middle of your paper, write the word natural, because naturally, Zach started at the number 1. He worked his way up. We're going to stop. We're not going to write all the numbers because that might take a while. All right. And then put a little circle. Okay. So you're a kid, start counting, right? Sort of show off to your parents. You can count all the way up to 100, right? Okay. All right. Then you're walking one day. All of a sudden you're walking and you step in a hole. And you're like, ow! Because a hole has like a bunch of empty space in it, right?
Oh, yeah.
Right? You stepped in a hole, which has an empty space, but there's a number that represents a hole. What number do you call that? 0, that's right. She said 0. 0 is right. So, except we're going to write the word hole with a W. Okay? Notice there's a hole inside of a hole. So we start with 0, and then go to 1, and then go to 2, and then go to 3, comma, dot, dot, dot. Put a circle around that. All right. Now you'll notice that all of the natural numbers are actually a part of whole numbers. All of these fit all of them, but not all whole numbers are natural. Some whole numbers are natural, but not all. All whole numbers are natural except, what's the only whole number that's not natural? 0. Very good. Right. So in elementary school, you guys, math is awesome. Math is fun. I got this whole number concept and natural number concept pretty easy. All right. And then you walk into your teacher's class, and they have this thing called the number line. And all of a sudden, the number line starts having these things called negative numbers. Your eyes get all big. You're like, oh my goodness. I thought they were only positive numbers. And students start getting negative about that. All right? Good. All right. So we have negative numbers and positive numbers. Now, the cool thing about this, you don't have to worry about fractions or anything. Okay? There's still just, no decimals. Right? What do we call negative numbers and positive numbers? Integers. That's right. Love that word, integers. And you'll love that word later. When you're working on a problem and I say, Ariel, I've got good news. The answer to the problem that you're working on is an integer. Then you at least know that it's going to work out nice and neat. Okay? Not an ugly decimal or something like that. Okay, that makes it a little easier. All right? So once you finally got the concept of these whole negative numbers and positive numbers, then the teacher throws in another curveball. You're like, parts of wholes? What's parts of wholes? All right? So this is where your concept of fractions started to build. All right? But a fraction, of course, it is a part of a whole. A rational number is basically, look at the word inside the word rational. What do you have? Ratio. It's a ratio of two, very important word, two integers. Okay? A ratio is, a rational number is a ratio of two integers. So for example, let's say I have the letter M and N. Give me a number, any number for M. 2. All right, what about N? 4. Come on. 7. All right, 2 over 7. There we go. I like that one better. All right. Now this is a rational number because 2 is an integer, 7 is an integer. It's a comparison of two numbers. By the way, you know what 2 7s can also be written as? Not just a fraction, but a decimal. That's right. So the decimal equivalent, 0.28571428557, and it just kind of keeps going like that. All right. Everybody knows that one, right? No? You look at me at me funny. Why are you looking at me funny? Cause? Oh, just because I look funny? Alright. So, this is the decimal equivalent. Alright, it repeats itself. There's a pattern here. See a pattern there? What do you think? What number is going to come out in the center? That's right. It just repeats over and over. So repeating decimals are rational numbers. Okay? They can be put in the form of a fraction. Alright? It has a pattern to it. So, let's see here. Is -4 a rational number? Sure. Because you compare -4 over 1. Alright? If I say -3 over 2, is that a rational number? Absolutely. Is 0 a rational number? Sure, like 0 over 1. Okay? Alright? Then we have, I'll put 2 sevenths, let it join. Alright? These are just random rational numbers. Alright, the number 2. You can put 2 over 1. All of these are considered to be rational. Alright? So, things that help me understand what rational numbers, they make sense. There's a pattern to them. It's a ratio of 2 numbers, okay? But then there's these pesky numbers over here. I'm going to put a separate little group. Alright? They're pretty cool. They're special, like radical 2. Alright? Or that awesome number we call pi. Alright? It does not have a pattern that repeats. Okay? So, we cannot express radical 2, or you cannot express pi as a ratio of 2 integers. Now, some people, like when you're in elementary school, sometimes teachers say, well, 22 divided by 7, we're going to use that as pi. Okay? That's an approximate value. Or 3.14, we're going to use as pi. Alright? Those would be rational, okay? Because they can be expressed as the form of a ratio of 2 numbers. These aren't. So what do we call numbers that aren't rational? Irrational, alright? Now, we got to be very careful about this word irrational in life. For example, alright, Jacob, just letting you know, don't tell girls that they're irrational. That would be bad, okay? Alright? Things you also say, why are you acting so great? Bad. Don't say that, okay? Also, if a girl's upset, you never say, calm down. That just doesn't work, okay? And never say all of them at the same time. You will not live, all right? No, I've lived through this, all right? 17 years of marriage, all right? I've learned things not to say, okay? I've never said them all at the same time. Usually one of those phrases, I realized that was a bad idea, okay? So, but these are irrational numbers. You cannot go to the store, Zach, and say, can I have square root of 2 pounds of ground beef, sir? You could, and if somebody was really bright, they'd be like, all right, I'm going to give you approximately 1.414 pounds of ground beef. That's the approximate value, all right, of it. Okay? Then you'd be caught off guard, like, oh man, I know those kind of stuff. But you didn't. Now, all of these numbers are considered to be real. They're real. It's part of the real number system. We're not part of the complex number system, which we'll get later, which has imaginary numbers. They're pretty cool. All right? These numbers are real. If you live in the real world, you'll come into contact with them, whether you like it or not. Okay? All right, so now let's look at our assignment here. All right? And the assignment says, name the sets of numbers. Not the set, but the sets of numbers to which each number belongs using the abbreviations. Now, I don't know about y'all being nice, you don't have to write the whole, if it's a natural number, you don't have to write the natural number. You can use abbreviations. So, if you're a little kid, all right, would you be able to eventually get to the number 34? Counting. Yeah, that's natural. By the way, all of them, everybody, all of them are real. So at least start out, everybody. At least put an R next to all of them, because they're all real. I'm not going to give you all of these, but they're all real. Y'all have your assignments up? You can pause it. All right, get your assignments out real quick. All right, so now that you have your assignment out, okay, we said 34 was a number that a little kid could count to. So So we know that's a natural number. So put the letter N as the abbreviated term for natural number. All right? But then we learned from our chart that all natural numbers belong in also what other set? Whole numbers. So I'm going over here, whole numbers, W. All natural numbers are whole. And all whole numbers are integers. So we're going to put the letter Z. And all integers are rational numbers, so we'll put the letter Q. The only set that it does not belong to is irrational. 34, you could totally go to the store and buy 34 apples. Okay? All right? Or 34 pounds of steak. If you have a big, a lot of people come. All right? It'd be really expensive. I would suggest that. Unless you have a sale at Skinner's. We have the $3.99 top sirloin. It's pretty good. All right? Now, what I want you guys to do is I want you to look at these numbers and not just name a set, but name all